Hey everybody, welcome to another VMware code session. My name is Madhukar Krishna Rao, or you can just address me as Madhu, anything's fine. I am a senior technical product manager with NSBU, that's the networking and security business unit. My core focus, at least in my day job, is around NSX automation and containers. And I kind of thought I'll put some of these together and then talk about kind of networking and security in modern apps, specifically focusing on Openshift containers, what we can do with it, how to integrate that with NSX for better security, visibility, and troubleshooting. So, yeah, I want to put this up here. Some of the things, or in this talk, I'll be talking about two things. One of it is already available in public. The other one is not. I'll be using Antria as a CNI in my Openshift cluster. So that's already certified by Red Hat. That's available for everyone to use. However, the part where I'll be talking about and showing the integration with NSX-T is not. It's going to be available soon. In terms of housekeeping, feel free to ask Q&A. I'll definitely pause in between and take a look at either the chat or if I don't know how the preference is. If you are able to just like speak up, that's fine too. I don't mind keeping this informal. I don't want all questions to be saved up all the way till the end. That said, the agenda is pretty straightforward. I'll be talking about what my solution or /lab or environment looks like. Basically, it's going to have Openshift. It's going to be on vSphere. It'll have Antria as a CNI and NSX-T. Then I'll be talking about deployment of the Kubernetes cluster, the Openshift cluster itself, and also show how Antria to NSX-T integration would work in peek into the future. So once you have the cluster up and running, I want to then kind of start talking about deploying an application, how you would be able to leverage the Antria policies, Antria cluster network policies, and Kubernetes native network policy with and without NSX, either way. Basically have a central policy management. And again, with or without NSX, Antria provides good troubleshooting options in terms of trace flow, in terms of looking at support bundles or logs. And with NSX, all of this is actually integrated with NSX2. So I'll be showing a bit of that. So that's the agenda. Any of these things, if you need to talk a little bit more deeper than what I'm presenting, please feel free to stop, ask questions. More than happy to explain a bit more. All right, that said, overall solution overview. Essentially, I like to look at this more as a, well, Kubernetes by itself is built with separation of concerns. So I'm kind of extending that a bit. I like to look at a network fabric, which is basically like an IaaS layer. Now, this could be Openshift, which I'll be talking about today, or it could be any other IaaS platform, right? It could be Tanzu or any other public Kubernetes cluster. Some of the integration or the bring up of the cluster is what would obviously change. But in terms of integration with NSX-T and the functionality that's available with Antria as a CNI, that's the same, irrespective of whatever platform you choose to pick. That said, Antria is a open source network plugin by VMware. We recently donated this to CNCF, so it's now a sandbox project. So all of the development happens on GitHub. You're more than welcome to participate, influence, and even contribute. We have actually had contributions from some of the big names from Amazon, Microsoft, NVIDIA, Google, Intel, I think Mellanox too. because there are cases where Antria is being used in some of these public clouds. So we've had good adoption and contribution around this. In terms of what Antria provides, it's a CNI. So obviously it does a lot of your IPAM, it does network policy, it extends the Kubernetes native policy. It also provides cluster network policies. Basically, you can apply policies at a cluster level. You can do it at a namespace level. I'll actually talk a little bit about that. What it does not do is obviously offer things like load balancing as a as a Kubernetes service. Typically, I would, at least in my world, I just typically deploy AKO. If time permits, I'll quickly show how you can do that in an OpenShift environment as well. It's pretty well documented. That said, a common question that I usually get at this point is usage with or working with a service mesh. It could be Tanzu service mesh or something else, but whatever I'm going to talk about, the integration with Antria works with any service mesh. It's a totally optional block you can put in. But once you do have all these things together, this kind of provides a very good platform for deploying any sort of modern application. It gives you good control over your IP address management. It gives you excellent security features. With NSX-T, it gives you great troubleshooting options. So yeah, I'm pretty excited to kind of look at this as a whole. Or as today's talk goes, we can just focus on a few of these components, right? Obviously, it's OpenShift, Antria as a CNI, integrating with NSX-T. In terms of prerequisites for this, I was trying to see if I could do this more as a code along session, but unfortunately the OpenShift cluster bring up, it takes about 45 minutes on my lab. It should pretty much take the same amount of time. And it's one of those 45 minutes where it's ideal to go have a cup of coffee or go finish your lunch. Not a great thing for a code along session. So what I've done is I have already pre-deployed the cluster. I will be talking about how I did that, the files used, whatever parameters that are needed, what options are available. I have also recorded the part where it pretty much deploys the cluster. So I'll be playing a short video. We can definitely pause and talk more about it. But after that, the deployment of the Antria to NSX-T piece and the actual interworking with NSX-T, I'll actually be doing it live. That said, in terms of setup itself, you need to kind of know about OpenShift. So OpenShift has good documentation on their site. Since I'm deploying it on vSphere, that's the direct link for deploying the OpenShift cluster on a vSphere platform. So OpenShift, if you're most of you might be aware, has two kinds of installation methods, right? IPI and UPI. With Antria, we'll be using the IPI method, so which is infrastructure provided, installer provided infrastructure, something like that. So essentially, all I need to do is specify the vSphere parameters in terms of, hey, this is my username, password, what data store do I need to deploy my compute and control clusters in, some networking details, and then just literally issue a single command, which will then kick off the cluster deployment. The cluster deployment itself is completely automated through the OpenShift installer executable. It basically first deploys a bootstrap VM. It will then deploy a couple of or three controller VMs. I think up to version 4.7 or 4.8, minimum is 3 controllers and 2 worker nodes. I believe in the newer versions, they are reducing it so that you can have a much smaller form factor. Then once the cluster is formed, you can actually interact with your cluster using the OC CLI tool. This is OpenShift controllers in my view, this is like a wrapper around kubectl. So you can do pretty much all the kubectl commands with OC, plus a little bit more. So you can do like OC get nodes and show namespaces and things like that. Any integration with Openshift or for the CNI perspective, it requires an operator. So we do have an Antria operator available. Again, it's open sourced. It's also certified by Red Hat. Version 0.13, Antria version 0.13, I think is the one that's currently certified. We are working with Red Hat to certify the latest 1.2 or 1.2.3 Antria version as well. The reason why it is this way is the certification process working with Red Hat takes a little bit of time, obviously, multiple companies. So by the time we had submitted version 0.13, got it certified, Antria 1.2 was already released by then. So hence the difference there. Antria release by itself happens once every 4 to 6 weeks. We try to keep it very quick. You are more than welcome to look at the GitHub pages or the Antria official documentation pages, submit feature requests, look at the roadmap, upcoming changes, attend community meetings, which are open to all. I think they happen on a weekly basis. All the information is there on the Antria documentation page. Okay. All right. In terms of actual setup to bring up your Kubernetes cluster, with the IPI method, it's actually very straightforward. The only thing that you would need, apart from making sure you have your vSphere resources in place, is to make sure there are some DNS entries, because the way the cluster operation works, the cluster formation works, is that there are cluster APIs that goes back and forth between your Bootstrap, between the control plane nodes, and they all operate on an FQDN. So it is important to have a resolvable DNS. In my case, I just have a bind DNS server, and these are the two important, absolutely needed FQDNs that I've already configured. So one is cluster ID.domain name, and my domain name is madhu.lab in my setup. This provides your API virtual IP. There is also another ingress virtual IP that is needed, which has the very specific format star.apps.clusterid.domain name, which is already configured. So from an infrastructure perspective, DNS entries, absolute must. And then to bring up the cluster itself, you need something called the install config YAML file. Again, there is documentation on this on the Openshift documentation page, but I will be opening up my file and kind of talk about what I did to get my setup up. That said, I think I'm pretty much done with all these PPT slides. I maybe have one or two just as a demarcation in between. But all right, let's look at the cluster creation itself. One thing I want to say is, if you're using any CNI, whether it's Antria or I don't know, NCP with OpenShift, you can change the CNI only during a cluster creation. Once the cluster comes up, you cannot change the CNI. There is one exception, but that's more from the Red Hat side. There is some discussion interest between the two companies to kind of relax this a little bit, but as of now, you can only select Antria as a CNI during cluster installation. Okay, so let me go into my lab. I hope my font size is visible and it's readable. Okay, I'll talk about this setAnt environment alias that I have. I'll talk about this too. So first thing that you would need is, or maybe I'll also show you the documentation page. This is the Red Hat documentation page. This is on per Openshift version numbers. I am using 4.7, so that's why I have this page open. They do talk about all these minimum resource requirements on your vSphere environment, the DNS requirements, SSH key requirements, and the sample config YAML file for vSphere. Plus, it also talks about IPI and different installation options, and again, user provisioned or infrastructure provisioned. So you can definitely go through this entire page. It is quite comprehensive, but you can jumpstart by just looking at some of these. All right, the install config file. It's not a big file, at least for my environment. It's not that big at all. It's hardly 34 lines, including the big secret. What all does it have? It basically defines what your control plane looks like in your cluster and what your worker nodes look like. So here I just say that I have 3 compute control plane nodes, and I want to deploy 2 worker nodes. This is the bare minimum in the version of Openshift cluster that I'm using. Otherwise, you're free to increase this. What I've also found, again, this is just my experience. My ESX hypervisors on which I'm deploying this, these virtual machines are physical ESX hypervisors. I have found the Openshift cluster to be a little bit sensitive to I/O lags. If there is too much of nesting happening. So if possible, just have ESX hypervisors and then directly try to deploy, or physical ESX hypervisors and try to deploy your Openshift cluster on it. Okay, in terms of the metadata, the only thing that I need to, or that I'm providing, is the name of my cluster. This is for reference. Andrea will also be using this name to create a couple of objects on the NSX side when we look at integration. Plus, this is also the name of the cluster that will be used in your DNS entry. So make sure they match. So what I'm talking about is this. Yeah. So in your DNS entries, when I say cluster ID, that's basically defined here. Okay, network type, the CNI type is Andrea. There are other supported ones, but obviously we are looking at Andrea today. Then you need to specify your cluster CIDR. This is the IP range from which all of your pods will start getting IP addresses. Machine CIDR, this is for the VMs itself, the control plane VMs and the worker nodes. And your service network for any services that are going to be created. That's all that you need to provide from a networking perspective. On the platform side, because again, this is IPI, this is what you need. So obviously I'm saying that this is a vSphere based platform. This is my vCenter IP or domain name, username, password, data center, data store on which all my virtual machines are going to get deployed. My segment or my DVPG from in the vSphere world distributed port group to which all my virtual machines get connected. This need not be a NSX managed segment. In my case, it is, but you're free to use a regular VLAN back segment or an overlay network. The cluster name, and then I need to specify the API and the ingress web. I need to define it here, because these IPs are going to be injected in the VMs so that the communication happens proper. And this is the same IP that is configured in my DNS server. All right, and then we have some pull secrets so that the jump host that I'm using right now will be able to, if needed, log in to the controller VMs or the worker node VMs for any troubleshooting or just checking on a few things. If you want SSH into those virtual machines, you need to provide the SSH key. and the pull secret. That's it in terms of what you actually need to start deploying a cluster. Let me pause here and see if there are any questions. None so far. All right, great. Okay, so I mentioned that I've already deployed my cluster. So even otherwise, right, let me show you my vSphere environment. So yeah, this is my data center, my cluster on which I'm deploying. This is pretty much what you saw in the YAML config file. I just have one physical host and all of my cluster VMs are deployed on it. This is what you would need. And as I mentioned, let me look at networking. So it is connected to a NSX managed network. It need not be, just that in my case it is. And it currently has an IP from the range from here, from the machine sider. Okay. So defining this YAML file is, I would say, step number one. Step number two is making a copy of it. Because when the installation has two steps, one is creating a manifest file or manifest files. The second one is deploying the actual cluster. And all of this is orchestrated and automated by Openshift installer. I'm not doing any heavy lifting here, but what it does is it actually consumes this YAML file and then creates a bunch of manifest files, and this YAML file will be gone. So what I typically do is create a work environment or like a temporary folder. So I can actually show this. Copy install config to this. Okay, so this is all you would need as a starting point. After this, you would have downloaded the Openshift installer executable from the Red Hat site. You do need a Red Hat login to be able to download this. But once you have it, you can download it for a specific Openshift cluster version. So in my case, I just have an alias. My Openshift installer is of version 4.7.28. By default, I think I also had I think I had a 4.7.19 version as well. So the reason why this matters is when you're using an IPI installation method to deploy your OpenShift cluster, this version of your OpenShift installer defines what cluster version you will eventually get. So with OpenShift, so somewhere in the documentation, they talk about these creating the Red Hat Enterprise Linux Core OS machines, right, in vSphere. So basically, these virtual machines are of type Red Hat Linux OS, and they all have a very specific version. The way you control that version is by picking the correct OpenShift installer version. Okay, so in this case, OI version is 4.7.2.8. Okay, as I said, all you have is this install config YAML file. And then the very first step is OI or OpenShift install, create manifest. And as I said before, it is going to override this file. So make sure you have a copy of it before you run this command. This is fairly quick. What it does is creates these two folders. What I'm generally interested is in this manifest folder. It has all the YAML files that are auto-generated based on the install config YAML file that you had created. So it kind of reads that and then does a bunch of magic. Again, all the heavy lifting is done by Red Hat here, creates all these manifest files. Now, one thing that we need to do still at this point is add the Andrea operator manifest files. So what I mean by that is if you go to GitHub and look at the Antria operator for Kubernetes GitHub page, there is a bunch of folders, and one of which is deploy. And under that, there is a folder called Openshift. And this has the manifest files that are needed for your Openshift installation. It has some RBAC roles, role bindings. It kind of defines based on some of the constraints that OpenShift has, what sort of permissions your pods need to have, because Antria is run as a pod. So we need to define some of the permissions, some of the RBAC in these YAML files. However, good thing is you don't have to know all of these files. You don't have to edit all of them except two. And the two of them you need to edit mainly to enter the Antria UBI image URIs. So the first one is your operator.yaml. Again, pretty small file. It has a big note which says replace this with the Antria image. In my case, this is where I've hosted it. You can host it on any Docker registry. And this is for my Antria version 1.2.2. That's it. This is the only line I have changed. The second file is, excuse me, this one. Now this is the actual Antria's config map. It allows you to modify any of the feature gates. So by default, Antria comes with a bunch of features, or most of it is controlled through a feature gate. You can enable, disable them as you choose fit. So that's what we have here. By default in version 1.2, the important things that you would need is Antria policy. Basically lets you use the enhanced Antria network policies. So that's already enabled by default. I think Antria policy. Oh, there it is. Antria policy. There are two places where you'll have to enable it if you're using any other older version. But again, 1.2, it's enabled by default. The other one is trace flow. You will probably need it. Yeah, Antria proxy. But again, by default, you don't have to change any of these things. Just know about it, that this is where you can change. But the one place where you will need to edit is this guy. This again is the Docker image URI for the Antria image itself. So basically there are two container images, the Antria URI and the operator URI. This file has the link to, or the path to the Antria image, and the operator.yaml has the link to the operator URI. That's it. So all we do is copy all these files over into the folder that we just created. So go to OpenShift, sorry, not here, manifest, and copy all of these YAML files. Just blindly copy them over to this folder. That's all that it takes. Once you do that, I actually will be playing the recording of this one too. So come back to this root folder and do OI create cluster. That's it. Literally, that's it. I actually won't press enter right now because this is the operation that's going to take about 45 minutes. So what I'll do at this point is jump to my quick recording. It's 4 minutes or so, but I don't think we have to look through all of it because it does talk about, I mean, I go through some of the same things again. Oh, this is my install config file. And then I'm creating the manifest. Is there a way to speed it up? No, unfortunately. And then I'll be copying all the, this is what I mean. It's just a blind copy. Obviously, at this point, I have already edited the operator.yaml and the Antria config YAML file to update the URLs. But that's it. That's the only change I have done. So copy it over to the manifest file, just showing that everything is here or the changes are here. That's the change number 1. And I think I also show change number 2. Yeah, and then as I said, create cluster is the only command that you'll have to run to actually create the cluster. So what this does in the backend, let me pause the video for a second here, is it will start doing all the operation. And as I mentioned before, the Openshift installer executable version controls what Openshift version that you'll be using. And it automatically picks the latest stable version from the Red Hat site, downloads the OVA. It will then, if you look at it, it will actually first deploy a dummy or a temporary virtual machine with that image, and then it will clone the same image into all of these 5 different virtual machines. And while it is doing so for the master VMs, it does, depending upon what functionality it is supposed to do, the bootstrap process takes care of making sure this specific virtual machine is a control plane VM, and this virtual machine is a worker node VM. The bootstrap process is the one that takes care of it. We as a user who wants to just deploy this cluster, we don't have to worry anything about it. All right, so yeah, it's going to take, as I said, 45 minutes. On the vSphere side, you will actually see your OVA getting deployed, assuming your parameters, everything checks out, passwords, and you can log in properly. I have obviously sped up this recording. It downloading the OVA, depending upon your installation or your internet connectivity, obviously takes time. And then the first thing happens is the bootstrap VM comes up, and then only the master node comes up. This is by design. And then all of them do get powered up. And the booting process is also in sequence. What OpenShift does is that the bootstrap VM gets deployed first. It boots up, the API service comes up. Then, even though the master VMs are up and running at that point, they are trying to talk to the bootstrap VM. You can actually see it in the logs. Once the API service comes up in the bootstrap VM, then the control plane VMs get their IPs and then form a cluster, and then the API service actually switches over. At that point, if you're actually looking at the log, you will see that, hey, suddenly it says I lost my cluster connectivity, and then it forms it again. Again, all of this is part of the process. Eventually, after all that, you will start seeing your worker nodes coming up and they joining your cluster. I think I have some of the output here. So yes, basically first it tries to bring up the API service in the bootstrap node. Now, if your DNS entries are not correct, this is where you'll start seeing errors. This will either time out, you'll have some problems, but if you do, DNS would be the first place you would want to look at. After all this, the API service has now actually switched over to the control plane VMs, which means the bootstrap resources are destroyed. So OpenShift, when it says destroyed, it actually just powers off the VM. It doesn't really destroy the VM. So you've got to do that on your own. Again, it's waiting for it to initialize. Once it does, the install is complete. You will get an output like this. And it actually gives you the amount of time it takes or time it took for the entire process. Okay, and this is what I was talking about. So if you want to interact with your cluster, even during the cluster creation process, you can actually set your kubeconfig to this specific path. And if you notice, this is the path where you had initiated the cluster install command. So in the same folder, it would have created a folder called auth and then put the kube config inside it. So you just need to point to that, and then you will be able to interact with your cluster. Now, if you do this get nodes or whatever Kubernetes operation while the cluster is formed, sometimes you will get either it'll time out a little bit, because especially when the service is switching over from one to another, or you might not completely see all the nodes at once, in which case it's still forming a cluster. Just give it time, it'll come up. And it deploys, I don't know, the last time I checked, every version there are more and more pods that gets deployed by default. But what's important is to make sure the Antria pods have come up okay. Again, the two commands that I did, right, create manifest and create cluster, is the only two commands that you would need to do to deploy Antria as a CNI. Everything else is done by the operator in the backend. It would actually be putting the Antria node agent in every node, including the controller nodes and the worker nodes. So that's why you see multiple Antria agents. There's an Antria controller and the Antria operator pod that will be up and running. Without this, if there is any issue with image pulling or Antria is not able to come up, okay, your cluster obviously will not form. In fact, your bootstrap process itself will not complete, and you will see a timeout right there. Yeah, I think in the video, it just scrolls through. And yeah, that's the end of the video, basically, because that's what a cluster formation is. Let me pause again to see if there are any questions. All right, okay, now coming to the actual live part. So what I've done is, oops. This basically sets my kube config. And this is the same command that I showed in the video. So I have 3 masters and 2 worker nodes that are ready. There is another, as I said, OC is an extension of kubectl. It has other operations that you can do on the cluster itself. One of them is the get CO. I actually forget what the CO stands for, but it's an abbreviation. And it gives you the kind of the status of your entire cluster. You can see this cluster has been up since a couple of days. Version 4.7 and Antria version 1.2, 1.2.2. You can also see in Openshift, a namespace is a project. So you can look at that one too, or you can do the same thing. As I said, it has a lot of pods that are running that would be creating, and it'll come up, go down. All of this is part of the Openshift cluster formation. This is all expected. You can clean up the completed pods if you want, or you can just let them hang around. Okay, don't worry about this. This is my app that I had deployed. That's just stuck right now. Okay, so now that I have my cluster, I have my Antria as a CNI, you can actually start interacting with your cluster. You can deploy your app. If you want to deploy your LB, you can actually do that. You can create your network policies, do everything that Antria can do at this point. But then going one step forward, which is the forward-looking part, we are going to introduce Antria to NSX-T integration pretty soon. So what that means is NSX-T as will form like a management plane. It can then talk to your Antria cluster, whether it's on OpenShift or any other place where Antria is running, and then give you visibility into all the networking CRDs or network policies. It'll give you visibility into all the inventory items like your namespaces, pods, and the other important thing is it also converts all the labels on your pods or namespaces into tags in NSX. If you're familiar with NSX, a lot of things in NSX are driven by tagging. Pretty much every object can have tags in NSX. So it automatically converts that. Now to do that, all you got to do is, again, let me go back to that folder. You need another interworking YAML file. Now this again, the interworking YAML is the main YAML file. It has all the definitions for all the parts that it creates. You don't have to edit any of this. It's just there. One thing that you might want to edit or look at is this bootstrap YAML. This is there only to help us in this state. You don't have to use this because the communication between your Antria cluster and NSX-T is based on principal identity. If you're familiar with that, it's basically authentication with NSX using certificates. So your passwords are not sent out in plain text anywhere. You don't even have to enter it. But in my case, I wanted to have a simpler way of creating a principal identity and use it. So this is the YAML file for it. So in a typical production environment, what you would do is create the principal identity beforehand using a normal NSX API or UI method, and then just use that principal identity for your Antria to NSX-T integration. So here, all we care about is the NSX password, username, password, the NSX manager IP address, the name of the cluster it's going to register as. That's it. Again, it talks about what you would do if it is a production environment, how you can specify your cert and key if you've already created the principal identity user. And then there are these Docker image files, interworking, and the bootstrap images. These need to be copied over to all of the individual nodes. Now, again, because this is more of like a tech preview, I am copying it manually. But as we get closer to having this ready for release in a GA format, this operation will be done by the Antria operator. So right now I'm showing this to you, but you don't have to know about this. So all I do is this. So basically I'm doing, for every node in my cluster, I first copy over both tar files, and then I log into each and then load these images. That's it. So this is where having the SSH key in your install YAML will be helpful because this way it's not, it can seamlessly log in a passwordless manner. This again takes about 5 minutes or so, and to save that time, I have already done this operation on all the nodes. So all I got to do is apply these bootstrap and the interworking files. Oops. And if we look at pods -a at this point, you will see the bootstrap pod getting created. It'll run and then it'll complete. This is expected. And then interworking.yaml. Again, this will actually have a pod that is running. Everything looks good. So once this is done, so now if I go look at my NSX manager, let me open up my NSX manager. Again, this is with Antria to NSX-T integration. Otherwise, you can continue to use Antria as a standalone CNI. The first thing that you will start noticing is, if you're familiar with the NSX UI a bit, under Fabric nodes, we have a separate pane for container clusters. In my setup, I just, right now, I registered this cluster. The status is going to turn green. Right now, it's doing the handshake and making sure it's downloading all the inventory. Especially on the Openshift side, there is almost 200 or so parts that NSX reads, creates the tags, and then does it. So it takes a couple of seconds more. But this is a standalone Kubernetes cluster with Antria, and this is on TKGI environment on my lab. But essentially, once integrated with NSX, you will actually start seeing information like this. Okay, so I just refreshed the screen. Everything is up and running. The other thing that you will notice is, as I said, the principal entity. So OCP, yeah, this is the one. This is a principal entity. It'll have enterprise admin rights. It's a principal entity user. And this is what would be used to create all of your objects in NSX. The next one is under inventory. If we go under clusters, Antria OCP, you will see that all information about the nodes, about the labels, this is expected. It's going to turn up green soon. All the pods, and if I look at the pods, all the labels are also translated to NSX tags. So Antria itself is doing a lot of heavy lifting in this case. And then you have Kubernetes services. It will detect everything. Interesting thing to note is this, and we'll soon see that these counters or numbers start increasing. Okay, so till now we created the cluster. We were able to integrate that with NSX. We now have all the inventory information, and it's now time to deploy my pods or application, right? So I'll go back here. I have a very, very rudimentary YAML config file, which basically deploys 3 Ubuntu containers and does nothing. It just sleeps for some time. Now, one thing to notice is that irrespective of whether you're using Antria or integrating that with NSX, your interaction with the cluster for a developer remains the same. You're still continuing to use your Openshift cluster, use your OC commands to do your normal operations. Okay. Get the pods. As I said, don't worry about terminating one. It'll eventually disappear. In my setup, again, because it's on my lab environment, resources are always in a constrained state. So it does take some time. And this will eventually come up. But what is interesting is, remember we saw pods. We can actually go to namespaces. The default namespace in the OCP cluster, this is where I deployed the pods. You will see all pods already visible. Some of it is, these two are down because this is the one that's terminating. These are the new ones that I just deployed. They're already up and running. I have the node information. I have the IP address information. More importantly, I now have the label information as tags. So this means I can now start creating groups in NSX. So I can create something called, let's say, client, set the members, select my Antria, say that you can select based on namespaces, services, or pods. I'm going to pick a pod, tag. It kind of pre-fills all the labels that are available for you. This is pretty cool because now all I got to do is, I know in my case, this was the client. I had named it, or I had put a label there with said client for easy picking. So I'm just going to select that, apply, and save. So now that you have this dynamic group, any new pods that come up with the same label is automatically added into this group. So again, we don't have to do anything extra. You're just going to operate with your cluster like normal. But now comes the interesting part. So what you can do at this point is pick a category. Antria also has different tiers. So if you look at OC get tiers, these are the different categories that Antria provides by default. Some of these come with Antria, some of this come with NSX-T integration. There are kind of duplicates, but that's going to get sorted out soon. You are free to select any tier. You can deploy your rules in any of these tiers, they have their own precedence, they have their own priority. The higher the number, the greater the priority. So which means that these rules get enforced first, and all the way at the end, you have, I think, application, and then even after that is baseline. Baseline is, for example, is a place where probably you will have like a catch-all rule. Now, ACNP stands for Antria Cluster Network Policy. So right now there shouldn't be any network policies, and also standard Kubernetes network policy. Oh, there is one that I've already applied. So this is web allow all. Let me look at what that is here. It's basically a simple network policy on the default namespace, right? So what you will start seeing is in the inventory. So if I go back to inventory, containers, namespaces, under the default in Openshift, if I expand, you will actually see the network policy that was applied through kubectl. This was not done through NSX or any other way. This was done directly through OC command by interaction with your Kubernetes cluster. So part of the Antria to NSX-T integration is that you also have visibility into all the network policies within your cluster. You can look at the details, which pretty much tells what's there in my YAML file here. And again, going forward, you will be able to edit from NSX UI too. So essentially, our vision is to be able to have NSX be the central place where you can manage your network policies across multiple Kubernetes clusters. All right, so I think I wanted to create another one from NSX Manager. Let me quickly do that. So go back to security, distributed firewall. Let me just pick the default application there. Let's say OCP policy. And I want this to be applied to my Antria cluster on my Openshift platform. Okay, create a rule. I think I created for client. Let's say I want to allow all traffic coming to the client. Let's say allow publish. Just a UI refresh, everything is successful. So now at this point, if I do look at my network policies, they are still the same. But if you look at the Antria cluster network policies, you will see that the policy that you defined in NSX is automatically pushed to Antria, and this happens pretty quick. And you can actually do describe. And it kind of tells you the same thing. It's applied to a specific pod selector based on this group. The action is allow, and what this group is Antria also has a feature called cluster groups. So see get these are the different groups Antria has created because of the group that are created in NSX. So they automatically get converted into Antria's object type and get implemented. So yeah, so basically from a security perspective, either you can interact with your cluster directly through the CLI or through NSX Manager, but you have a way to do both. The reason why this is super exciting, at least for me, right? Because if you're, let's say, an enterprise admin or a NetSec DevOps admin, you can define rules which are applicable at a cluster-wide level. You can say that, hey, this specific I don't know, namespace should not talk to this other namespace, or this specific production environment should not talk to this other production environment or staging environment. And then you can let your developers still continue to deploy their apps, continue to use their network policies as they seem fit, but you still have an overall control of how the environment behaves. Okay, let me quickly pause for any questions. Okay, all good. Now that's from a networking perspective, right? In terms of, I kept talking about visibility and troubleshooting. So I want to make sure there is some time left for it. In terms of visibility Antria itself has a little bit of a couple of monitoring CRDs that are implemented. So if you actually go to antria.io, this is the main place for Antria. It has excellent documentation in terms of getting started to installation on different clouds and all the feature sets. So I think all the network policy stuff is here. Troubleshooting, there is also trace flow and stats, flow visibility. Now, what happens is if you just have Antria as a standalone, you can still look at your flow information using AntCuttle. That's a simple CLI that we provide, command line tool to interact with the cluster. Or these with NSX-T integration, these actually get converted into NSX-T or flows that NSX-T can understand, which means you can start seeing if there was any traffic happening at this point. You will start seeing statistics here. And if you extend this, once you have NSX-I or NSX Intelligence in your setup, you will actually be able to export that, or NSX Intelligence will be able to consume it, and now suddenly start seeing everything that's happening within your container environment. So that's on the stat side. In terms of troubleshooting, NSX always had this trace flow where you could inject trace flow packets to go from one VM to another and then kind of look at every packet hop. You can do the same with Antria. Now, this is something that you can do natively with the Antria as well as a CNI through AntCuttle command line tool. Or again, if you have NSX, you now have a nice clean UI. So let me select a cluster. I know I just, created my Openshift cluster. Let me just do a ping, doesn't matter. Let me say from my client to my server. Oh, interesting. I don't remember which is the right one, but let me pick a different cluster. So let me pick, okay, add service to I don't know, front end. This is another app that I was playing around with, another cluster of mine. But essentially, this is a similar kind of an output you will start seeing. So in this case, it's a single hop, which probably means it's on the same node. So both pods are on the same node. So hence, it's just a pod-to-pod communication. If it was traversing across multiple nodes, you'll actually see every hop. And if it was going through any of your firewall rules, whether it was allow or deny firewall rules, you will actually see that. And if there was any packet drop, you will see a red icon here with the exact network ID, the network policy ID, which you can always go look at your cluster or look at NSX Manager to figure out what exact firewall rule is dropping your packet, which I think is pretty cool. Finally, in terms of logging and for troubleshooting purposes, you can always look at Antria logs. You can collect, there is a support bundle option in Antria. Oh, there's a troubleshooting section somewhere. Troubleshooting, and there is a support bundle. Support bundle in Antria natively, but we have extended that into NSX as well. So which means if you go under NSX, go to support bundle, not only can you get information about your NSX managers and edge nodes, whatever, but you can also select your Kubernetes clusters, whether it's OpenShift or otherwise. So here I'll select my OpenShift cluster, select a very specific node that I'm interested in, or select all of them and collect a bundle. Again, this just helps with operations. All right, let me quickly check on my slide deck if I've missed out on anything else. Nope. So we looked at cluster creation, integration with NSX-T, some bit of troubleshooting, and then yeah, that's want to just conclude at this point. Let me again pause for any questions. Right. Over NCP, what are the trade-offs? Excellent question. So both NCP and Antria are going to be available through VMware. Both are supported. Just that Antria is also open sourced. There is a commercial version. There are some differences like tiered RBAC available in the commercial version of Antria. That's not there in the open source version. In terms of other trade-offs, if you know or if you're familiar with NCP, the container interface show up as a logical port in NSX, which means it's kind of like a, or I like to call it a first-class citizen, which on the other side also means that at this, as and when your NCP cluster grows, as and when you scale, you start hitting your NSX limits in terms of number of ports, segment ports that needs to be created, or firewall tags that you can have on an object. But with Antria, because the enforcement is done in Antria and NSX is providing just the management plane, you can actually scale much, much, much better with Antria. That's one difference. The other thing, if you're specifically talking about OpenShift, if you are interested in deploying OpenShift as a bare metal cluster, NCP works only for version 3.x of OpenShift. If you are looking at 4.x OpenShift cluster as a bare metal solution, you need to pick Antria. This is primarily because between 3.x and 4.x, Red Hat changed their the VMs that get created. So NCP is not able to inject all the services it needs to inject, because everything is containerized in the 4.x release cycle through Red Hat. So Antria is a much better fit. These are kind of the high-level trade-offs. In terms of feature sets, again, both, if you consider NSX integration, both of them have pretty much the same kind of feature sets. Visibility into your networking, control over network policies, troubleshooting options. Yeah, is what I can think of at the top of my head. Any other questions? All right, excellent. Sorry, I'm 2 minutes over the time limit. Thank you all for the time and staying with me till the end. Yeah, thank you for the opportunity.